Okay, we got chapters 2 tests coming up here, so let's go over the review here. As you know, the review document that I'm going over here will be posted on Canvas, so you can look at it and check it out for yourself. All right. Section 1, vocabulary. Another name for a conditional statement is an if-then statement. The two parts of conditional statement are the hypothesis and the conclusion. And in order to prove that a conditional statement is false, you need to find a counterexample. All right, lots of vocabulary here. So, if a conditional and its converse are both true statements, then you can write each as a biconditional using the words if and only if, or the abbreviation IFF, or as I like to say, if. A blank is a statement you assume to be true. That would be a postulate. And another name for that is an axiom. And a theorem is a statement that you can prove using previous theorems or postulates. Remember, a postulate you can't prove, but a theorem can be proven. All right. I like to keep saving this periodically, so all right. Station number 2, the property station. All right. Now, each of these is going to match up with one, so let's start with the following. Number 1 is an example of the distributed property. Distributed property, and I will cross that off right there. If R equals Q, then Q equals R. That's just flipping, and that is symmetric. If 2x plus 5 equals 8, then 2x equals 3. How did we get to that? We subtracted 5 on both sides, so that would be the SPOE, or subtraction property of equality. Now, number 4, x plus 7 equals x plus 7. That means that both left and the right are equal to each other, so therefore that would be reflexive. If 2x, or if x equals 2y, then 4x equals 8y. You have to multiply both the left and the right by 4. So that would be an example of the multiplication property of equality, or MPOE for short. Now, number 6, 4a plus 16a minus 9a equals 11a. You combine all the like terms together to get one term. That's simplify. And number 7, it says if x equals y and x equals 3 to z, then 3z equals y. Well, that's an example of the transitive property. Transitive property. And we could also probably say substitution with that, but we'll leave it at transitive for right now. Okay. Now, I've used everything but just a few things right there. So let's see what happens. We got negative 6x equals 42, and then x equals 7. That's an example of dividing by negative 6, or DPOE for short. And then number 9, that's an example of the substitution property. The substitution property, or we can also say transitive. Substitution and transitive, in most cases, they would work well with one another, but let's kind of leave it where it is. Okay, and then this last one is APOE. So each one of those blanks is used. All right, these are all terms you need to be aware of with what's going to be on your test coming up here in the coming future. All right. Okay. Number 3, station number 3, that is. It says, write the 2 sentences that make up the biconditional. Okay. It says, today is Monday if and only if tomorrow is Tuesday. All right. Now you're given that the biconditional, it's a biconditional. That means that the conditional and the converse both have to be true statements. Well, how do I write the conditional from this? Well, it's very easy. You just simply take off the if and only if and replace it with if and then. So if today is Monday, then tomorrow is Tuesday. And then just flip it around. Converse, if tomorrow is Tuesday, then today is Monday. And you know they're both true, because if they weren't true, then you couldn't write it as a biconditional. So if you start out with a biconditional, you know that both the conditional and the converse have to be true statements. All right. Let me try to slide this up just a little bit, see what it does. Doesn't do much, but you know what? We'll try what we can. All right. I'd rather you see this than my face anyway. So, all right. So that's that. Okay. Section or station 4, that is. All right. Now, let's look at the following. Here's what I know. I know that these 2 angles are supplementary. So I know that 2y plus 50 plus 5y minus 17 equals 180. I know that. So I add them together. I get 7y plus 33 equals 180. When I got 7y equals, and I subtract 33, 147. Well, if 7y equals 147, and I divide by 7, that means that y equals 21. And the same thing goes right here. These 2 are also supplementary. So I got 7x minus 248 plus x plus 44 equals 180. So that means that 8x minus 204 equals 180. So when I add 204 to both sides, I get 8x equals 384. And I cannot do the mental math right at the moment, so I'm going to take out a calculator, which you, of course, can use. And I got 384. And I'm going to divide that by 8. Normally, I have my calculator on the board here running, but for some reason, it's not working right. So we get 48. So x equals 48. So divide by 8, so x equals 48. Okay. Now, here's one thing we know. Let's look over here. I know that 2x plus 25 and 3x minus 10. I know that these are equal because they're vertical. So that means that 2x plus 25 equals 3x minus 10. And I knew that these were supplementary, so I'll write those up here. Supplementary. and supplementary. All right, so now I have, if I solve for x, subtract 2x, so I get 25 equals x minus 10. I add 10, so therefore x equals 35. That's my value of x, is 35. But in order to find y, I have to know the measure of the angle. So I plug it in here. I can plug it into either one. I just plug it into this one. So this is going to be 2 times 35 plus 25, which is 50 plus 25, which is 75 degrees. Correction, I'm wrong. My math is wrong. Oops. Let's fix that. It's 2 times 35, which is 70, plus 25, which is 95. So that angle is 95 degrees. And then I know that y plus 95 equals 180. So therefore, if I subtract 95, I know that y equals 85 degrees. All right. Now I'm running short on time here, so I'm going to go ahead and stop this, and we'll continue with part 2 here in just a moment.